The idea of building intelligent automaton stretches far back into human history. Early science fiction promised human-like mechanical creatures. When a real robot debuted at the 1939 New York World's Fair, he was an object of awe and excitement.
And so, ladies and gentlemen, with a great deal of pride and pleasure, I present to you Electro, the Westinghouse Moto Man. Electro, come here. And here he comes, ladies and gentlemen, walking up to greet you under his own power. You see, all I need to do is to speak into this phone, and Electro does exactly what I tell him to do, sometimes. But I don't see why I'm telling Electro's story when he's perfectly able to tell his own. So let's listen and see what Electro has to say to us today. All right, Electro, will you tell your story, please?
Who? Me?
Yes, you.
Okay, Toots.
Robots of the 21st century come with a little less attitude, but far more functionality. Electro's skills were limited to being able to smoke a cigarette, blow up balloons, and move his hands and legs. Boston Dynamics' Atlas robot demonstrates almost human-like agility. As well as humans, robotic engineers take their inspiration from the natural world. The flick-flack spider, found on the edge of the Sahara Desert, can propel itself into the air by somersaulting and rolling. Festo's bionic wheel bot is designed to walk and roll like this spider. To start rolling, the bionic wheel bot bends 3 legs, each on the left and right of its body, to make a wheel. 2 legs extend to push the rolled-up spider off the ground and continuously push it forward. This prevents the bionic wheel bot from stopping and ensures it can move itself forward even on rough terrain. Like its natural role model, the artificial spider rolls faster than it walks. The robot can even climb uphill. Through developing robots like this, bionics experts are creating devices that can traverse difficult terrain. Festo's bionic flying fox is based on the only mammal in the world that can fly. This ultra-lightweight winged robot is able to move semi-autonomously in defined airspace. With a wingspan of 228 centimeters and a body length of 87 centimeters, the artificial flying fox weighs just 580 grams. Its wing kinematics mimic the natural flying fox, including an elastic membrane which continues from the wings down to the feet. Like the real thing, the bionic flying fox can control and fold its wings together individually. The flying fox is tracked by 2 infrared cameras that feed images to a master computer. This controls the flight and feeds algorithms to the flying robot, enabling it to learn from every flight and constantly improve its performance. Festo's Bionic Swift is an aerial robot that uses the agile swallow as its inspiration. To make maneuvers as true to life as possible, the wings of the robotic bird are modeled on the plumage of real birds. Individual membranes are made of an ultralight, flexible, but very robust foam. Like real swallows, the Bionic Swift travels in a flock, with 5 machines able to move in a coordinated and autonomous way, interacting with a radio-based GPS. Intelligent networking of flight objects contributes to technology that could be used in the network factory of the future. Geolocation data could streamline processes and anticipate bottlenecks. And flying robots could transport goods around warehouses. Not content with creating artificial creatures on the ground and in the air, Festo is also working on underwater robots. The bionic Finwave is able to swim collision-free through a pipe system made of acrylic glass, thanks to ultrasound sensors, in the same way dolphins and pilot whales find their way through dark and murky waters. With an undulating fin motion, the bionic fin wave swims confidently through the pipe, using 5 ultrasound sensors to constantly measure the distances to the walls and ensure it's propelling itself in the right direction. While Festo's impressive robot range is still in development, Boston Dynamics has brought its robots to the marketplace. After years of testing, Spot is now available for sale, attracting buyers who need a robot that can cover rugged and dangerous terrain that wheeled robots can't manage. Spot has 360-degree vision and obstacle avoidance. It can be driven remotely or taught routes and actions to perform autonomous missions. The American-based company plans to commercialize some of its other prototypes as well. Big Dog was developed for the American Department of Defense as a possible pack mule for soldiers in terrain too tough for wheeled vehicles. To help it navigate difficult paths, it has a variety of sensors, including a laser gyroscope and a stereo vision system. Little Dog has 4 legs, each powered by 3 electric motors. The legs have a large range of motion and the robot is strong enough to climb. Little Dog's sensors measure joint angles, motor currents, body orientation, and foot-ground contact. One of Boston Dynamics' earlier robots was Wildcat, which paved the way for its current technology. It was the fastest quadruped robot on Earth, able to reach speeds of 32 kilometers an hour while maneuvering and keeping its balance. Wildcat's main purpose was to push the boundaries of robot flexibility and speed. Petman is a tethered Boston Dynamics robot developed to test chemical protection suits. It's the first human-like robot that moves like a real person. And robots that move like people are an aim of South Korea's Naver Corporation. Their prototype, Ambidex robotic arm, can be controlled by a 5G network from anywhere in the world. It has cable-driven mechanisms that makes interactions with humans safer and has potential applications in manufacturing and defense. At just 2.3 kilograms, Ambidex weighs less than a human's arm. It can be operated at a speed of 5 meters per second and can carry up to 3 kilograms. The robot arms can support high-speed, wireless, real-time control from remote locations, using 5G brainless robot control technology. The arm is controlled over a 5G wireless link using complex sensors and the latest 5G data management. Advanced robotics technology has the potential to transform people's lives, making the human-robot partnership one of the keys to a better tomorrow. 86 million kilometers from Earth, the Mars Space Laboratory begins its descent to the Red Planet. It's heading for a landing target in the Aeolis Palus region of Gale Crater. Hurtling through the Martian atmosphere at a speed of 5.6 kilometers a second, the spacecraft's instruments are monitoring the atmospheric conditions and performance of its heat shield. As the heaviest craft ever to attempt a Mars landing, the laboratory experiences the highest heat flux and shear stress ever faced by a vehicle's heat shields. It pinpoints its target, a 3.5 billion-year-old crater, and carries out the most accurate Martian landing of any spacecraft. On board the laboratory is the Curiosity rover, a car-sized autonomous robot, specially designed to navigate the planet's rugged and rocky terrain. Curiosity's mission is to investigate the Martian climate and geology, search for evidence of microbial life, and provide data that can be used to plan a human expedition to Mars. Crammed with scientific instruments, the 899-kilogram rover is powered by a generator that produces electricity from the decay of radioactive isotopes. This should keep it alive for at least 14 years. Robots like Curiosity are helping scientists access places humans can't reach. But for a successful mission to Mars, the robots first need to be tested on Earth in the right conditions. The rocky deserts of Utah in the United States can be a good substitute for the Martian landscape. Scientists from the Robotics Innovation Center of the German Research Center for Artificial Intelligence test their robotic systems in Utah by simulating a complete mission sequence. Mission control is in Bremen, Germany, more than 8,000 kilometers away. The successful tests give scientists important insights into the robustness and mobility of their systems. Another robot being developed for space exploration is the Spacebok, a jumping space robot that flies like a spacecraft. Built by a Swiss student team, Spacebok follows the example of astronauts who found themselves hopping rather than walking on the moon due to its low gravity. The team is slowly increasing the height of the robot's repetitive jumps and have reached up to 1.3 meters in simulated lunar conditions so far. The prototype has performed so well that they even used it to play a live-action game of Pong, the classic video game. The Spacebok is just one of the innovative products tested at the European Space Agency's Planetary Robotics Laboratory. The lab supports research, development, and testing of the two main robot types used in planetary robotics: rover platforms and sample manipulation systems. It evaluates planetary probes before they even reach the drawing board stage, saving time and money. There are many exciting innovations in the pipeline, from transformer robots that can convert their wheels to legs, to a robot trash collector that will use its forelegs to grab space debris from orbit. Scientists are even studying the possibility of soft robots, with the ability to move sinuously across rocky surfaces. One European Space Agency experiment focuses on an intuitive human-robot interface, designed to solve even complex manipulation tasks. The Subfis Justin project is testing the possibilities of managing significant communication lags while commanding a robot to carry out dexterous work. German astronaut and geophysicist Alexander Gerst is excited by its potential.
Subfis Justin is a fantastic experiment because it takes human-robotic interaction up to a new level. We have a test here of a robotic system that is controlled by an astronaut in a spacecraft, in a space station in this case, and the robot is actually located on the surface of a planet. Well, in this case, it's a test planet, it's Earth, right? Later on, this could be Mars, it could be the Moon. All right, I'm coming a bit closer to the SBU-1. The scenario is as we are the crew on orbit around Mars, and we send a rover down there as the first scout to see how the conditions are like, whether it's safe, what the atmospheric parameters are. And so we command that rover, but the difference to how rovers were commanded in the past is that this rover actually knows to navigate by himself. So I don't have to tell him every millimeter to move in which direction or what to do exactly, but I just give him high-level commands like check out this solar panel or pick up this rock, and he will actually do that.
It's not just space where it's useful to have a robot to handle hazardous conditions. Animal is the world's first autonomous offshore robot. Equipped with a customized sensor head, the four-legged robot autonomously performs various inspection tasks on an offshore converter platform in the North Sea. The 320 kilovolt converter station has a 960 megawatts power transmission capacity, making it the world's most powerful installation of its kind. It can power more than 1 million households with clean energy. Animal helps to reduce the risk of disruptions and ensures the security of the electricity supply. The robot monitors machine operations, transmits sensory readings, and detects thermal hotspots and oil or water leakages. At any time, Animal can be remotely operated from an onshore control center to provide real-time information through the robot's onboard visual and thermal cameras, microphones, and gas detection sensors. Robotics, the company that created Animal, has the motto, "Let robots go anywhere." The four-legged robot has also undertaken an inspection of Zurich's sewerage canals, a labyrinth of drains and tunnels beneath the Swiss financial center. NASA's Puffer robot traverses difficult terrain using just 2 wheels. Flattened like cards, a number of microbots can be stored in a larger, 4-wheeled robot and deployed when it's necessary to explore smaller spaces. Scientists plan to try them in dangerous places like volcanoes. As well as saving us from danger, robots are partnering with humans to take over the grunt work in some industries. At a Barcelona plant operated by the automotive giant SEAT, 8 autonomous robots can transport more than 2,000 parts per day. The robots communicate with their surroundings and regulate traffic by controlling the traffic lights. Known as an Automotive Guided Vehicle, or AGV, these robots use the latest technologies in navigation recognition, 4G connection, and induction electric battery charging. But robots are just one part of the intelligent workplace. Samsung is using 5G connectivity to create dynamic networks that will transform the factories of the future. In a 5G-enabled smart factory, real-time communication among millions of sensors, devices, and systems will have the capacity to improve environmental safety and quality control. In Samsung's own factories, advanced technologies are improving daily operations, ranging from storage to manufacturing, transport, packaging, and shipment. This is possible by combining 5G networks with artificial intelligence, robotics, the Internet of Things, and mixed reality. When these technologies work together, they allow more intensive monitoring of products and manufacturing equipment, reducing the likelihood of defects. Robots can do the heavy lifting, working non-stop and at a steady speed that can't be matched by human endurance.
From human to robot, back to human again. The combination of a human with a robot overcomes the many limitations of a human being.
Automotive manufacturers have been swift to perceive the benefits of robotic strength. Hyundai has developed a new Vest Exoskeleton, or VEX, a wearable robot created to assist workers who spend long hours working in overhead environments. VEX enhances productivity and reduces fatigue by imitating the movement of human joints to boost load support and mobility. wearable vest functions by combining multiple pivot points with multi-link muscular assistance, eliminating the need for a battery. At 2.5 kilograms, VEX weighs 40% less than competing products and is worn like a backpack. The concept of an exoskeleton comes from the tough external shells of animals, such as beetles and crabs, where a strong covering protects the body underneath. Some of the earliest human-designed exoskeletons were created for the military to increase soldiers' endurance. Today, tests are underway to see if it's possible to incorporate robotic technology into items such as clothing and footwear. At Nissan, line workers now wear a robotic exoskeleton that supports their legs, shoulders, and back, reducing the stresses normally placed on their bodies by up to 60%.
We are here in Nissan Barcelona, where we assemble the parts of the cars. There are some workstations where the operator needs to work with hands over head position, so this can make a little bit of stress of the muscles, and we are in search of some solutions to improve this condition.
In Spain, we have the Catalan Automotive Cluster, which is composed by a group of companies working together to improve the current conditions of the industry. They had a project to introduce the exoskeletons in the automotive industry, and we saw the chance to gather with them, to collaborate. The exoskeletons help us to reduce the muscular efforts during certain operations. This results in less fatigue for the operator.
The first time I put on the exoskeleton, it was a strange sensation, but as I carried on working, it felt more and more practical to have my arms supported. There are various models, but I found one that was the most practical and, in the end, the most comfortable to work with.
After the trials, we find that with the use of the device, we can reduce up to 60% of muscular effort. In Nissan, we have a lot of new technologies that are used in our cars, so we want to also use new technologies for our employees. We have been trying these new technologies with a very good results.
As the partnership between robots and humans gathers pace, there's no limit to what can be achieved. Matching human ingenuity with the speed, power, and strength of machines will transform our lives in ways we can only imagine.